Find dy by dx if y is equal to x square minus 2x plus 4 times x minus 1. Now since both these terms are algebraic, so it's possible to multiply these two brackets. So we'll multiply the two brackets and then take the derivative, so that will become more easier. The other option is we can apply the multiplication rule and then simplify. So here we'll first simplify and then take the derivatives. So let us simplify this function here. Let's multiply. So x square into x, so that's x cube, x square into negative 1, so that's minus x square. Now minus 2x into x, that is minus 2x square, minus 2x into minus 1, that's plus 2x, and then 4 into x gives 4x, and 4 into minus 1, that's minus 4. So we have y is equal to, the first term is x cube, minus x square minus 2x square is minus 3x square, 2x plus 4x, that is 6x, and we have minus 4 over here. And now we could easily differentiate with respect to x. So differentiating with respect to x, we have dy by dx is equal to, now here we could take the derivatives of the individual terms applying the addition and subtraction rule. So we have derivative of x cube, then minus 3 into derivative of x square plus 6 times derivative of x, and lastly the constant term, that is derivative of the constant term 4. Now derivative of x cube is 3x square minus 3 times derivative of x square is 2x plus 6 times derivative of x is 1, and derivative of constant term is 0. So we have the value as 3x square, here we have minus 6x plus 6, and if we take 3 as the common factor, so within brackets we'll have x square minus 2x plus 2. So this is the value for dy by dx. Find dy by dx if y is equal to x raised to 4 plus 4 times x square minus 3. Now let us simplify this expression on the right hand side and then differentiate with respect to x. The other option is we could use the product rule directly and get the value for dy by dx and then simplify. So here we are going the reverse. We are simplifying first and then taking the derivative. So let us multiply the brackets. Now x raised to 4 into x square is x raised to 4 plus 2, that is x raised to 6 using indices. Then x raised to 4 into minus 3, so that's minus 3 times x raised to 4. Next we multiply by 4, 4 into x square, so that's plus 4x square, and 4 into minus 3, that's minus 12. And now we differentiate with respect to x. So we have dy by dx. Now here we take the derivatives of the individual terms. So we'll have derivative of x raised to 6 minus 3 remains as it is. It's the coefficient, so minus 3 times derivative of x raised to 4 plus 4 is the coefficient, so 4 times derivative of x square minus 12 is a constant, so the last term will be derivative of the constant term, that is 12. Now using the rules for differentiation, derivative of x raised to 6 is 6 times x raised to 5 minus 3 into derivative of x raised to 4 is 4 times x cube plus 4 times derivative of x square is 2x minus derivative of constant term is 0. So finally the answer is 6 times x raised to 5. Now minus 3 into 4, so that's minus 12 x cube plus 4 into 2x, that is 8x. So if we could take a common factor, say 2x, if 2x is taken as the common factor, then we have 2x into, here we have 3x raised to 4. Now 2 6 is 12, so minus 6 times x square plus 2 4 is 8, so plus 4. So this is the value for dy by dx. Find dy by dx if y is equal to 3x square minus 2 times 4x square plus 1. Now let us perform the multiplication of these two brackets before we take the derivatives. Else we could also apply the product rule directly. So let us perform the multiplication and then go for dy by dx. So if you multiply the two brackets, now we'll have 3x square into 4x square. Now 3 into 4, that's 12, and x square into x square becomes x raised to 4 using indices. And 3x square into 1, so that's 3x square. Now we multiply by minus 2, so minus 2 into 4x square, that's minus 8x square, and minus 2 into 1, that's minus 2. So we have y is equal to 12 times x raised to 4. Now 3x square minus 8x square is minus 5x square minus 2. And now we differentiate with respect to x. So differentiating with respect to x, we have dy by dx is equal to, now we take the derivatives of the individual terms. Now 12 is the coefficient, so we have 12 times derivative of x raised to 4. Next, minus 5 is the coefficient, so we have minus 5 times derivative of x square. And negative 2 is a constant, so we have minus derivative of the constant function, that is 2. And now we have the derivative value. So here we have 12 times, now derivative of x raised to 4 is 4x cube minus 5 into derivative of x square is 2x minus derivative of constant 2 is 0. So we have dy by dx as, now 12 into 4, so that's 48x cube minus 5 into 2x, so that is 10x. So this is the value for dy by dx. Find dy by dx if y is equal to sin x into cos x. Now here we would be applying the product rule to obtain dy by dx. Now we know that derivative of, now we're discussing the product rule, derivative of u into v is given by u into derivative of v plus v into derivative of u. So it's first term into derivative of second term plus second term into derivative of the first term. So applying this product rule over here, we have, so we just mentioned differentiating with respect to x, we get dy by dx is equal to, so we have sin x into derivative of cos x plus cos x into derivative of sin x. Now proceeding further, we get sin x into, now derivative of cos x is negative sin x plus cos x into derivative of sin x is cos x. So sin x into negative sin x gives us negative sin square x, and cos x into cos x gives us cos square x. Now if we arrange the terms, we obtain cos square x minus sin square x, and we know that cos square theta minus sin square theta could be replaced by cos 2 theta. So applying the formula over here, we get dy by dx equal to cos 2x.